Hello method students. In this PowerPoint, you will review some of the skills you have learned in Methods 1 last semester that will be essential to produce graphs with your database. First, you have to be able to determine really easily which variables are explanatory and which are response variables in your databases. Usually you're really good at that, but make sure you know well. For example, if you want to correlate gender and hours of physical activity in your subject, gender will be the explanatory variable and hours of physical activity will be your response variable. If you want to make a correlation between drug use and academic performance, drug use will be your explanatory variable and academic performance will be your response variable. If you want to correlate the use of cell phone and academic performance, here the use of cell phone is your explanatory and academic performance is your response variable. Last example, if you want to make a correlation between the use of social media and body image of a person, the use of social media will be the explanatory variable and the body image will be the response variable. The same variable can be explanatory or response variable depending on the question you're asking. For example, here, the use of social media can be a response variable if I want to make a correlation between the gender of a subject and his or her use of social media. But the same variable can be an explanatory variable if I want to make a correlation between the use of social media of a subject and his or her body image. Another important notion about variables that you have learned in Methods 1 is the notion of categorical versus quantitative variable. A quantitative variable is a quantity, a number and a quantity. For example, your age, your mark, your score at something is a quantitative variable because it's given as a number, as a quantity. A categorical variable is a category. Yes or no, gender, kind of electronic device you use in school, type, your favorite team sport. These are all categorical variables because they're categories. And there is something very important about categorical and quantitative variables that you have to keep in mind when you produce your graphs, is that the same data you collect, the same question sometimes in your survey, or the same code in your content analysis can be expressed either in a categorical way or in a quantitative way. The next slide shows an example of that. If you ask your subject, what is your age, and you use it as an open-ended question, the person put a number. This is a quantitative variable. It is a quantity, a number of years of age. But if you ask the same question, what is your age, and you put choices of answers, 15 to 17, 18 to 20, or 21 to 23, these are still numbers. But your question, the type of question, the way you ask it, makes your variable here categorical, because you have three categories of ages. Sometimes when you do your spreadsheet in a statistics software, you can turn an open-ended question into categories if you need it. One example is my teams working with substance use or the use of alcohol. You can ask your subjects, what is your age? And make it an open-ended question. So it becomes a quantitative variable, but you can add a column in your database, a column that would be called underage or legal age to drink alcohol. Those below 18 are underage, and those above 18 are legal age, 18 and up. So it becomes here a categorical variable. So you can play with these notions. You don't have to, but you can play with these notions when you do your database in a statistics software. But the most important thing to remember here is the way you ask your question and ask for an answer sometimes can make the same question a categorical variable or a quantitative variable. Now, when it is time to make graphs to illustrate your data, you need to remember two things. You need to graph two different things. First, you will make graph to describe your data. And then you will make graphs to make correlations with your data. When you describe data, you use only one variable. You describe your database. When you make a correlation, when you make a graph to illustrate a correlation, you use two variables to link them together. You will start by producing graphs to describe variables, and sometimes you will have to describe qualitative variables. So in this case, as you remember well from methods 1, you will have to use a pie chart or a bar graph. Do not use clustered bar graphs here, because by doing a clustered bar graph, you already make a correlation between two different variables. So pie charts and bar graphs are ways to describe one qualitative variable. Now, most of teams will be using Excel instead of SPSS because it's much easier to access it from home. I will guide you when it's time to do it, and it is pretty easy and straightforward to make graphs with Excel. It's user-friendly, so don't worry about that, and you will learn it when it's time to learn it. You know how to do it with SPSS, so it's even easier to do it with Excel. When it is time to describe the distribution of one quantitative variable, I hope you remember from methods 1 that you can use histogram or a box plot. With Excel, you will use a histogram here. And you remember that by having a histogram, you can see the minimum value of your distribution, the maximum, the mode. You can see if it's a pretty symmetric distribution, skewed left, right, and Excel also gives you the mean of your distribution. So there's a lot of things you can get from one histogram that describes one quantitative variable. After describing your variables, you will have to make correlations. And sometimes you may want to make a correlation between two quantitative variables. For example, you can correlate the number of times in a week someone uses drug and their academic average, or how many hours a week someone works out and their average. Usually it's not very common in the past that methods two students had to correlate quantitative variables, but it might be your case. You may want to make a correlation between two quantitative variables. In this case here, you will use a scatter plot. You have learned scatter plots in methods 1. You remember that usually the explanatory variable goes on the x-axis and the response variable goes on the y-axis. Y depends on x here, remember that. And you can see here if your variable is positively or negatively correlated. If there is no correlation, if there's a weak correlation, if there's a strong correlation, you can see that with your scatter plot. In a lot of cases, if I remember well from the past years, methods 2 students have to make a correlation between two categorical variables of their surveys and databases. For example, you want to make a correlation between the gender of students and if they use drugs or not. You want to make a correlation between their mark as a categorical variable and if they play a team sport or not, etc. If you remember well from methods 1, a good way to do that is to do a two-way table. You have learned that with expected counts and observed counts, and you do a chi-square test. Now, maybe not everyone has learned chi-square in methods 1. My students did, but I don't know about everyone. I will not ask you to make a chi-square test in methods 2. I have rarely seen students doing that in the past in normal life. So of course I will not ask you to do that this year. So you will not really be able to find the level of statistical significance between two categorical variables. But you will be able to find a strategy with Excel, a very good strategy to make a correlation between two categorical variables. And this strategy is the main one that was used in the past by my students using SPSS. Next slide. This strategy will be to use a clustered bar graph to express a correlation between two categorical variables. You can see a clustered bar graph here, and it's pretty easy to make with Excel, pretty straightforward, a couple of clicks. You see here the correlation between the gender of a sample of people and their hair color. So just by looking at this clustered bar graph, you can see that there is a correlation between being male and having red hair. No female in the sample have red hair. There is also a strong correlation between being female and having blonde hair. And more males than females have brown and black hair here. By looking at such a clustered bar graph, you can see correlations or the absence of correlations between two categorical variables. The only thing you're not able to do here is to find the level of statistical significance. That would be done with a chi-square test. It might happen that you want to make a correlation between one categorical variable and one quantitative variable. There are statistic tests for that you will learn during your university career that you have not learned in methods 1 and that I'm not expecting you to use in methods 2. But sometimes such correlations are pretty interesting to make. For example, from your databases, the correlation between the gender of a subject and the hours they spend working out. Gender is categorical. Hours of workout is a quantitative variable. Same thing for the correlation between the average mark of a person and if they use drugs or not. Using drugs or not is a categorical variable, but your average mark can be a quantitative variable or a categorical variable if you transform it into a category. But sometimes you might want to make some correlations like that. If it's your case, there is a way to do that with Excel. You remember you were splitting your file with SPSS. Or you might not remember, but you were doing that in methods 1 with SPSS and some labs. We were asking you to split a file, to split males and females, or to split drug users and not drug users. There's an easy way to do that with Excel. So I will show you how to do that. So if you want to correlate a quantitative variable and a categorical variable, you will split your file according to your categorical variable. You will separate males and females, or you will separate drug users and non-drug users, or you will separate those who work out or not. You will separate those who use a cell phone in class or not, etc. And then for each of these categorical variables, for each of these values it can take, male, female, drug users, non-drug users, you will produce a separate histogram. So you will have two separate distributions here, one for each of the values your categorical variable can take.